so for this question, we have a geometric series here, which you can see, and it's a limiting sum because the geometric series, there's infinite terms. And we can see it's geometric because the first term is just 1, and then the ratio between terms is minus x. And we're going to satisfy the conditions because if the absolute value of x is less than 1, that means the absolute value of minus x is less than 1. So the absolute value of the ratio is less than 1. And what this lets us do is we satisfy the conditions for a limiting sum. So the limiting sum, remember the formula is given by the first term over 1 minus the ratio, which in this case is going to be 1 over 1 minus x, which is 1 over 1 plus x. Right? So we've satisfied the first part. And now we want to find this sum. So we're asked to find this limiting sum, and what we can do is we can use the previous part. So it says to derive both sides here in the question. So if we do that to this equation, we get minus 1 plus 2x minus 3x squared plus etc. And on this side, this is 1 plus x to the minus 1. So when we take the derivative, we take the power down, take 1 away from the power. So we get minus 1 over 1 plus x squared. Okay? Now we can take negatives out. So we get 1 minus 2x plus 3x squared minus etc. equals 1 over 1 plus x squared. And remember, this equation holds for all x less than 1, where the absolute value of x is less than 1. So to get this equation we can sub in for x equals minus a half. And when we do that, notice that minus a half, the absolute value is less than 1, so it works. And we do that, we get 1 plus 2 over 2 plus 3 over 4 plus 4 over 8, etc. Noticing that the minus will become positive when we square. And on this side, we get 1 over 1 minus a half all squared. So this is 1 over a quarter, because a half squared is a quarter. So we get 1 over a quarter, which is just 4. So what we've determined is that the sum from n equals 1 to infinity of n over 2 to the n minus 1 is precisely 4, which finishes the question and answers, so that's the answer to the question. And we get what we need.